Okay, so one more lesson in this chapter, and in this lesson, I want to show you how we can extend type aliases, much like we can extend interfaces. And although the concept of extending type aliases is kind of the same as extending interfaces, the syntax is a little bit different. So let's jump right into an example. So then I'm going to create a new type, and in fact, I'm just going to paste this type in called person. And this person type must equal to an object where we have an ID property, which is string or number, and a first name property, which is a string. Now, let's create a constant. I'm going to say const person 1, and I'm going to set it equal to an object where we have the ID property, which is going to be a number 1, and also a first name property, which is going to be Mario. So this kind of adheres to the structure, right? We could say person 1 was a person, and this would be absolutely fine. Okay, so now what I'd like to do is create a new type alias, which extends this type alias. So the way we do that is by saying type user, and this is what the new type is going to be called. We set that equal to person, which is the type we already created, then an ampersand, and then curly braces to define the extra properties we want the user to have. For example, an email, which must be a string. And what we're saying here is, look, this type alias user is going to be the same as a person. So grab me this type alias, whatever this is equal to, and also extend that by adding this property to it as well. So it's the same as grabbing these things right here and pasting them in here and getting rid of that. Okay? So all we're doing is we're borrowing those properties from the person. So let me just add this email property back on, which is a string. Alright, so now I could create another person down here. I'm going to say const person2 and set that equal to an object, and the ID in this case will be a string this time, 2, which is fine because we said string or number. Then also we're going to have a first name, which is Yoshi. And then after that, we will do an email, and that is going to be yoshi@netninja.dev. Alright, so this essentially would be this kind of type user. We could explicitly type it to be a user, and we'd get no errors, because all of these properties should be present for a user. The person, which is these two, plus the email. Alright? So that works. Now let's create person 3, and in fact, let's get rid of this type right here for now. Let's come down here and say const person 3 now, and set that equal to an object, and all we're going to do is add an email property, and that will be peach@netninja.dev, right? So then, will this be of type user? Well, no, not really, because although we have the email right here, we're missing out these other two properties. So what I'm going to do now is show you a function. If I create a function called print, not rent, print user, and inside that function take in a user argument, which is going to be of type user. And then inside here, I'm going to say console.log, and then we'll log out the user ID. So user.id, first of all. We'll also log out the email. So user dot, we can grab them from here. It knows these properties because we're saying the type is a user. All right. So dot email, and then user dot first name. And notice it adds those first name and ID properties, even though in user right here, we don't explicitly declare them. We're just grabbing them from person, but it knows if something is of type user, it has to have those properties too. So we get access to them in this dropdown. All right. So now let's try passing these different objects into this function. I'm going to say print user, and then passing the first one, which is person 1. Now, is this going to work? No, it's not going to work because person 1 is not of user type. It doesn't have the email property right here. All right, so that doesn't work. Let's try the next one. Print user, and this time it's going to be user, or rather person 2. And this does work because we have all three properties. Awesome. Let's try the last one. Print user, and then pass in person 3. And this doesn't work either because we only have the email property in person 3, and we need the ID and first name. Okay, so this is how we extend type aliases, by saying what we want to extend from, and then an ampersand, and then whatever other properties you want this particular type to have. Okay then gang, so now I feel like we're getting to know a little bit more about TypeScript in general. I think it's time in this chapter to make a small project that's actually quite useful and also pretty fun to make. Now, in order to do this, we'll be using what we know so far about TypeScript, as well as classes. So, the first part of this chapter is going to be all about how classes work in TypeScript, and then the second part of the chapter at the end of it is where we'll make a little project, which will be a class that allows us to process any array of JavaScript objects into a CSV file. So it's going to be a fun little thing to build, and hopefully it's going to teach you how these different data types can be used in a real-world example. Now then, like I said at the start of the course, I am expecting you to already know a little bit about JavaScript, and it would be beneficial at this point if you knew a little bit about JavaScript classes as well. If you don't, then it's okay. I am going to do a quick recap in this lesson, but if you do want to dive a bit deeper, then I've got a whole course about JavaScript classes, which I'm going to leave a link to down below this video so you can check that out. So then, first things first, what is a class? Well, a class in TypeScript and JavaScript is like a blueprint for an object. We'd use it to describe how objects look and behave in terms of what properties and methods they can have. Now you might be thinking that sounds a little bit like an interface, and in some ways it is. But classes give us more features that interfaces don't give us, and they're also very different in some ways as well, and we'll discuss those differences as we come across them. But let's start by making a new class, and we do that by using the class keyword, and then the name of the class, which I'm going to call pizza with a capital P. Then we open up some curly braces. Now inside this class, we define what properties a pizza object should have. So let's do that first of all. So I think we're going to have a title. Every pizza needs a title, and the type of that is going to be a string. After that, I'm going to create a price property, and then that's going to be a number. That's the price of the pizza. After that, we will do a base property. So this is the pizza base, and this is going to be a very specific type that I'm going to create a new type alias up here. So type base. And remember, a type alias allows us to create some kind of custom type. Now, in our case, it's going to be a union type because I want this to be a string, but not just any string. It could only be one of 4 different strings, and those 4 things would be classic base, thick, thin, and maybe garlic. So we'll create this type alias base and set it equal to classic, and then or, so a pipe symbol, and then another string, thick, and then or, and then thin, and then or, and then garlic. So this type base now is basically a string. Only one of these 4 strings. We're saying it can be this, all this, all this, all this. So the type here would be now base to be one of those things. Alright, so after that, we will do a toppings property for the pizza toppings, and this is just going to be a string array like so. Awesome. Okay, so far this is still looking very much like an interface. We've got a name for the data type, and we've got a bunch of different properties and property types outlined inside it. But this is where things are going to get different, because a class in TypeScript allows us a way to create new pizza objects, whereas an interface doesn't. When we create an interface, for example, if this pizza class was an interface instead of a class, we couldn't then say something like const pizza is equal to a new pizza and invoke that. And that wouldn't generate a new version of this object for us. That's not how interfaces work, but classes can do that for us. So you can think of an interface as a way to enforce a structure within values, but maybe think of a class as more of a way to create objects with a certain structure. So when we run this code right here by using the new keyword, then it's going to log for this pizza class, and then it's going to use that class to create a new instance of the class. And by that, I mean a new object which has all of those properties right there that we define inside the class. So now if I type out this variable name and try to use a property on it, we're going to get auto completion for all the different properties on that pizza class, which is awesome. TypeScript knows about those properties on any pizza object and lets us know about them as well. If we try to access a property that doesn't exist, for example, ABC, then we're going to get an error. Alright, cool. So Now we're making a new object using this class which has those properties, but at the moment those properties will all be undefined because we're not actually giving them a value anywhere. It would be nice if when we create a new pizza object, we could pass in some arguments right here for things like the title and the price, and we can do that. So let me pass in a couple of arguments. The first one is going to be for the title, which will be a string, and we'll call the pizza Mario Special, alright? And then the second one is going to be a number for the price, so we'll say 15 for 15 pounds or dollars or whatever. So we're passing in these arguments now for the title and the price, but how does the class itself know that we want this to be for the title and this to be for the price? For all the class knows, this could be for something else, and this could be for something else. We could have other properties down here that were numbers and strings. Well, what we can do is we can create the constructor. And this is a special function inside a class, and the constructor can take in the arguments that we pass right here. So, for example, I could say the first argument would be the title, which is a string, and the second argument would be the price, which is a number. Much like a normal function, right? And inside this function now, we can set the values of these things. So I could say this.title to refer to this thing right here is equal to the title. We pass in this thing right here. Okay, now you can call this something else if you want. You can call it A, and this B doesn't really matter, but it makes not much sense then, does it? Because we don't know what we're meant to pass in. So I would call them whenever the properties are called, and then we set them this way. We say this to refer to the pizza itself, the pizza instance, and then the title property on that pizza instance, and we set it equal to the title argument that we pass in right here. We do the same thing for the price. We can say this dot price is equal to the price that we pass in. Alright, so now we have a value for the title and the price when we create a new pizza. So if I was to say something like pizza dot title now, that would give me this value, Mario Special, for this particular pizza that we created. If I create a new pizza, so if I say const pizza 2, and set it equal to a new pizza, and I pass in like Luigi Special or something, then the title for pizza 2 would be Luigi Special, right? Okay, so let's now give these two a value. So I'm not going to pass these in to begin with because I feel like these are something we might change later on. So we'll just give them an initial value. So the base could be a classic by default, but we'll give the user a way to update that later on. And the toppings to begin with are going to be an empty array. And again, later on, we'll create a function maybe to add new toppings. But now at least we have a way to pass in two arguments, the title and the price when we create a new pizza. And then we set the values of those to the properties right here, the title and price inside the constructor, okay? So then we can also give a class different methods. So let's come down here and do that. So these methods are going to be basically methods we can call on this pizza object right here. And they're going to do things like maybe update the base, or add toppings, or maybe remove toppings, and so forth. So let me create the first one. We'll say add topping. This will be the first method for the class. And then we'll take in an argument, which will be the topping we want to add, and that is going to be a string. Now it's not going to return anything, so we'll specify void right here. And then we'll open up the code block. Inside here, all we need to do is take this dot toppings, which is the toppings property right here, which is an array, an empty one to begin with, and then we can use the push method on that to add on the topping we pass in. So I could say down here, for example, pizza.add topping, like so, and it could be mushrooms. We could do another one. I could say pizza.add topping, and we could pass in maybe olives. And now this pizza, if we said pizza.toppings, would give us an array which has mushrooms and olives inside it. Alright? Cool. So that's the first method. Let's do another one. Let's create one for removing toppings. So remove topping, and then in here we will pass in the topping we want to remove, which is a string. Again, it's not going to return anything, so we'll say void right here. And inside this function, we basically want to filter through the current toppings. If we find this one we pass in, then remove it. So I'm going to paste this in. We say this dot toppings is equal to this dot toppings. The array currently is dot filter. We fire a function for each topping, which we're taking right here. Now, if that topping is not equal to the topping we pass in, then we keep it in the array, right? So this will return true, meaning we keep it in the new array, which we assign over here. If they do match, then this will be false, and that means we filter out of the array, so we're removing that particular topping, alright? Alright, so let's do the final one to select the base, and right here we'll take an argument which is b of type base. So it has to be one of these things up here. And now we're going to return void. Inside this function, we can just say this dot base is equal to b, what we pass in. So let's try adding a base as well. We'll say pizza dot select base, and then we'll pass in, let's just try passing in something that doesn't exist, like crispy, right? Like so. Well, we get an error. We're not allowed to do that because it must be of type base, which is one of these things. Pretty cool. And the good thing is, when we're typing here, if I say something like, oops, a string, we can see all of these options right here. So it knows that it must be of type base, and it knows that type base is one of these 4 options. So it shows those 4 options right here. So let's choose the garlic base. Awesome. And then finally, let's just log this pizza to the console. So let's say console.log, and then pizza, which is this object. Now we should see the toppings, the title, the price, obviously, and also the base. Alright, so let me save it first of all. So if we open up the terminal now, we should see down here, yeah, we see that pizza with the base garlic, toppings, mushrooms, and olives. Title, Mario Special, and the price is 15. Awesome. So that's the basics of classes in TypeScript. In the next lesson, we're going to look at something called access modifiers. Okay then, my friends, so we have this class now which has a few properties and methods. And when we create a new instance of that class, we can specify the property values of the title and the price. The base and toppings are given initial values, but we can update them using these methods down here, which we do on our instance. Now, at the moment, we could directly access and change all of these properties on our pizza object by just saying pizza dot, and then whatever property we want to access, and then we can update that value to be something else. Now, that's fine if that's how you want to work, but a lot of the time, it's better to make it so that these properties can't be accessed directly like this. And instead, they get updated through methods that we expose, like these ones here. That way, if another developer uses our code base at some point and makes new objects using this class, it's less likely they're going to implement it incorrectly. In essence, we'd be making our class like a black box, and just exposing small entry points to it that can update or do certain things. And we have ultimate control over how that works. So in order to achieve this and to make it so these properties can't be accessed and updated directly from instances we create, we can use something called access modifiers. Now, access modifiers are basically keywords we can place in front of class properties and methods, and they dictate how those properties and methods can be accessed. By default, when we don't add any modifier to something, that property or method becomes public, meaning we can access it directly from the instance of the object as we just did. It would be the same as adding the public modifier in front of a property like this, alright? But what I'd like to do is make these properties private, so they can't be accessed directly from any instance of this class. And to do that, we can just use the private keyword in front of the property or method. And that means that this property now can't be accessed directly on this pizza object that we have down here. But importantly, it can still be accessed within the class itself, like inside the functions. So when we call these methods, everything still works. So let's make all of our properties now private. So I'm going to put private now in front of this one here, the price, then in front of the base, and then also in front of the toppings. And like I said, just because these are private right here, doesn't mean we can't access them from within these functions. We can. This refers to the instance itself that we create of the pizza. Then when we access toppings, we're allowed to do that. It's just that out here, outside the class, if I now try to say pizza dot, we don't get access to the toppings, the base, or anything like that. I never try to do that. say pizza.toppings and hover over this, it says property toppings is private and only accessible within class pizza. Alright, so now we're kind of protecting those different properties by making them all private. Now there's one more thing I'd like to show you, and that is a little shortcut for this right here. If we're taking in arguments, which are going to be set on the pizza like this, and those properties are declared down here, we can actually get rid of these. We can get rid of this. And instead we can put the access modifiers directly in front of the arguments. So if I say private title is a string, and then private price is a number, this little bit of code right here does exactly the same as setting them and making them private right here. So we can actually get rid of these now, and we can get rid of this. And this now does exactly the same thing as before, only that is much easier. So if we're ever setting properties when we first create an instance of a class, and we pass them in right here to the constructor function, then we can actually use access modifiers in front of the arguments inside of the constructor function, and that's going to set these properties on the class instance as private. You can also use public as well if you wish, like so, and that's still going to set it. But if we don't have any access modifier right here, then we're not going to have a price property on the pizza. And I can demo that if I say down here, pizza dot. We don't have a price property, right? It's not working. However, if I put public up here, I'm going to say public price. I can come down here and say pizza dot, and we can see the price now. So he has set it as a property on that instance. Now I don't want it to be public. I want it to be private. So let's change that back to private and save it. And now we're kind of just protecting these different properties a little bit more. Alright? So that's access modifiers. In the next lesson, we're going to look at how we can use classes as types for arguments in functions.